Hello everybody. My name is Dominik Miodunka. I'm first time on TATHAC and I'm very excited and happy to be here. I think yesterday was great. Today I will talk about the EVAS, the Evolved VAS Solution for legacy VAS systems. But first, a few words about myself. I'm a CTO of ProIDS. We are a company based in Poland and we provide professional services in the area of integration, software development and support services, mostly for telco operators. I've been in consulting and system integration business over 15 years. And I worked on different types of convergent architectures throughout my career, from fixed mobile convergence to telco to IT. And in the area of today's topic, I can say that I participated in different roles in migration of multiple legacy platforms to open solutions to next generation IN systems. So how we came to this EVAS concept? This is something which we've been discussing with our customers. We are implementing parts of it, as I will tell you later, but it all comes from looking at the trends in telco, which were already mentioned during those days. So we can definitely see that that operators are ready to accept open source in the network, open source solutions, and also the hardware which is needed to run this is cheaper and cheaper and more available. So this leads to the fact that those days, this combination of open source and commodity hardware can be used as a mainstream, as a full-blown telco solution, basically. So this is one factor. The other thing is that, as it was already mentioned in other presentation, we see the evolution, for example, in the packet core. There is transformation which is happening, which involves virtualization, consolidation of systems, and the EPC is a great example of that. So Affirm Networks, there's a US company which has received $51 million funding in C-Series venture capital, and this is not like, you know, the big name like Ericsson or Nokia. This is maybe not known to everybody, but this is a good example that this is the right direction. And the third item is that there are multiple systems in the operator's network which share some common features, and they belong to the same category, and they are not providing the core services, but still those which are needed. The mobile operator especially, cannot do without them. So when combining those items, we combine three parts: the low layer, the hardware, the operating system, virtualization, and cloud, with the available open source middleware, different types of systems, and the multiple VASs which are required. And this brings us into the Evolved VAS, the EVAS platform. And just so that we are on the same page, what kind of value-added services I mean. So, of course, there are the well-known SMS service, multimedia messaging service, or USSD gateway, which are used by the end subscribers. But also, we are talking here about, for example, equipment identity register or GMLC, and even different types of flavors of PBXs are possible, and solutions VAS like ringback tone, for example. Of course, this is just a few on the list. This is not a definitive list. We can think about, for example, voicemail as a feasible, but some of those we are already implementing for our customers. So the next thing is the question: why to change? Why it's wise to think about moving from a silo VAS to a evolved VAS, which would contain multiple of them. So as I said, currently we have multiple systems in the operator network from different vendors, which are on inconsistent platforms. So many integration points, many items, many integrations which are repeated, and there is redundancy. And of course, this is complex and not so easy to maintain, which results in, well, the fact that this is expensive to maintain. So we have high capex. And of course, we are speaking here about the old technology. So those systems, well, are not so flexible. I can give you an example. We have talked with one of our customers recently who has a system which for management it requires a web browser, but it requires Internet Explorer 6. And it's really difficult to change this. I mean, the vendor could do it, but it's, well, not cheap. So this is one reason that probably when, for example, due to marketing needs, there is need to introduce new features, it can be very difficult on those old systems. And of course, we can also think about end of life, both in terms of the hardware layer itself, where the VAS is running, or the solution as such. And here we come to the question, why to move from a single VAS to a new single VAS, possibly doing an upgrade. Yes, so we can think here about how to approach this, how to approach when we face those challenges. And we have several options. We can, of course, put the evolved VAS on dedicated hardware. We can use the virtualization approach. We can do it on private cloud, and we could do it on public cloud. What I think and what we found out is that operators are not ready yet for the public cloud. So our preferred approach, the ideal would be to do it on private cloud, and this is something which we are pushing. However, in practice, what we are implementing is a mixture of private cloud and virtualization approach, because well, that's the reality. That's the reality in current circumstances. Moving to an overview of the platform. Oh, something happened with a warning. No, this is just a joke. I thought that it would be a good exercise, you know, to guess what are the different elements. But since we have no time, I will explain them to you. So on the lower layer, we have, of course, the hardware, which is the base for the whole solution. Then we have the virtualization management layer, which we built based on OpenStack. We have the platform management function, which serve for the performance management and fault management, and of course, this is the whole operation maintenance integration with the other O&M systems in operators network. For the VAS solutions which we think of, we need the connectivity to the signaling. So the connectivity gateway, which provides both SIP signaling and SS7 signaling. We need both in current for current VASs, and also some type of database, for example MySQL. But the core of the solution is the virtualized execution environment. And here the important thing is that we have different VAS flavors, each running on a separate virtual machine. I will talk a bit in a minute, in a few slides, about advantages of such approach. To add some sugar on top, we have the exposure layer, which provides the API exposure like REST or SOAP, or different types of other protocols are possible. And the GUI, which is to be distinguished from the platform management GUI. This is the GUI used by end customers. Sometimes for some types of VASs, this is needed. So this is the whole. This is the overall architecture. Now drilling down a bit into details. Okay, we divided this whole architecture into 3 areas. So the database part and the signaling servers, as I mentioned, this is what we put on virtualized hardware. However, the cloud is used for the processing part, for the VMs which run the VASs. So here we get all the advantages of cloud approach, meaning that we can scale up and down as needed traffic-wise. We can bring up specific VASs which we need. And as I mentioned, we use OpenStack as the base for that. In the virtualization layer, we use KVM and Proxmox for those parts. What is also important here is that this whole architecture is composed of different open source systems. As the VAS runtime, we use James Lee technology. We use here Telestack's products, but those are the whole system is composed of different open source components. So what is important is to put some kind of measurement, some kind of monitoring between the different elements in the platform, so that we can have discovery of any faults and properly handle those if they appear. So this is very important to integrate. What is also important for our customers is the handling of multiple NATCOs, but yeah, I will get to that in one moment. And here you can see the example for one NATCO, which has like 3 flavors of VAS, so SMS, USSD, and GMLC, and all are scaled independently. So, for example, if we need more SMS power at a given time, we can bring up more virtual machines with SMS capability and shut down some GMLCs if they are not needed. So, this is what you would expect from cloud setup. This is done automatically by proper KPI measurement. However, for this solution which we built, we put a connectivity gateway which has a single integration point with customer network. So this one is not scaled, and we observe that there is sufficient capacity here on this layer. So this is not the issue. The main issue for scaling and shifting resources is in this VAS cloud area. However, when you're thinking about a single operator, well, you may think that the benefit here is not so huge, because anyway you need to reserve the amount of resources. But things get interesting when you think about a multi-NATCO setup. So, okay, this is maybe not so visible, but still you will have access to the slide. So here we have a multi-NATCO scenario where we have 3 NATCOs, X, Y, Z, and each of them has a different set of VAS which needs to be run in the network. So we cluster those VASs. They're running on one virtualized management layer. However, they are handled separately. So we have some isolation here, and that they form the independent areas, the independent management areas. They are having their own thresholds, their own KPIs for management. This is something which we are discussing, this approach with our customers, but it seems that this is quite interesting. We are currently implementing, let's say, the step back for one NATCO. So I think this would be the next step. Here we also have the database, which can be separated if needed. So, for example, this could be put in different locations in different countries, but also this could be consolidated in one location. This is all depending on particular scenario. Yes, we can say that the same applies for the operating for the operations management part, where also this could all be run from single network operating center, but this could also be due to different operational reasons distributed in different countries. And similarly, on the connectivity gateway layer, there are sometimes some requirements or constraints on the integration side, which lead to the fact that, okay, this would need to be separated per NATCO. So basically, we are talking about a flexible approach. We are using a blueprint here. So this is not something that we have a productized product. We are talking about a blueprint composed of different open source components. And the main challenge here is to properly integrate those components and to provide a custom-based custom solution which fulfills the exact needs. So for that we apply the process of analyzing particular needs of the given customer. We select the best suitable components. So as I mentioned, we use telestacks, but also for the SIP balancing, for example, we don't use currently the F5 switches, but we use Camalio as SIP load balancer. We use MySQL as the database. Also different types of LDAP technology. I mentioned about the virtualization, which we use, and the cloud technology. So we select the best setup for particular needs, and in the end we put it into life. We put it into production, and of course at the end we support those solutions. But my colleague Irek will talk about this in next presentation. And I can say that this is happening now. So we are implementing such VAS solution for our customers. Okay, so to sum up, what are the VAS benefits here? So first of all, we have a single consolidated platform which reduces the overhead in the network, and it can support multiple value-added services. It definitely reduces OpEx. So such solution would be cheaper in operations than the legacy VAS platforms. And third, but not least, we have a scalable, flexible, and extensible solution. So one of our customers started with a set of VAS applications, VAS systems, and then they decided that when they saw how the platform operates, they decided that they will add new ones. So this is something which can be extended and can grow as needed. So this was a brief overview, so thank you very much, and I'm here to answer any of your questions. If you want, please discuss details, please catch me later during the break. Thank you.